Chapter 8 is on polynomials and factoring. There's a lot of vocab in this chapter, so make sure you learn that and are comfortable using it and understanding what those words mean. We'll start by going through some of that vocab. The word polynomial itself means many terms. Poly means many, nomial means terms. Degree is the highest exponent in a polynomial, and so if you have something, the highest exponent is a 2, you would have a degree of 2. Standard form is when all of the terms are written in alphabetical order and the exponents are written from greatest to least. So you want to make sure if a question says to put it into standard form, you would rearrange it so that the exponents are greatest to least. There's two ways to classify polynomials. The first is by degree. It's by that highest exponent. So if you have a highest exponent of 0, which would be like x to the 0, which is really just 1, you're going to have a constant term. If your highest degree is 1, so like x, you would have a linear term. If your highest degree is 2, x squared, you'd have a quadratic term. If your highest degree is 3, it would be x cubed, which is a cubic, and x to the 4th is a quartic. Each of those functions will look different, and you know what a lot of those functions look like. If you classify them by the number of terms, meaning if there's 1 term, it's going to be a monomial, 2 terms, binomial, 3 terms, trinomial, 4 terms, polynomial. So you want to look at that prefix there, mono, bi, tri, poly. So if you use those prefixes, that can help you determine how many terms are in that polynomial. Okay, next we're going to move to operations with polynomials. To add and subtract polynomials, you want to look for like terms, and you're going to combine those like terms, regardless of whether it's adding or subtracting. And again, just a reminder, for like terms, they have to have the same exponent and the same variable in order to match. If you're multiplying, if you do a monomial times a polynomial, that's just going to be distribution, like you know how to do. And you can use those exponent rules to change the variables and the exponents there. When you do any sort of polynomial times polynomial, which would be anything bigger than a binomial, you would want to make sure that every term in your first polynomial gets multiplied by every term in the second polynomial. Now there's a couple of ways and methods to be able to do that. In my class, I taught you how to do the arrow method and the box method. So for example, if we have a binomial times a binomial, meaning it's a binomial because there's 2 terms in each piece. I'm going to start by rewriting my 2 binomials here. Now to do the arrow method, you're going to take your first term and multiply it by the first one and the other one, so that's x squared. You're going to take the first term, multiply it by the second term in the other binomial, so we get x times -4, so that's where -4x. And then you're going to take your second term in the first binomial and multiply it by the first over there, so you have +7 times +x, so plus 7x. And then the last one would be the 7 times -4 is -28. So you can look at those colors to help match up, but the most important part is every term in that first binomial is multiplied by every term in the second binomial. So now you're going to look for like terms. We have -4x and +7x, so those are like terms. We're going to combine those. So we get x squared, -4 plus 7, we get plus 3x minus 28, and that would be the multiplied out version of those 2 binomials. Now the other method that we have is the box method. So to use this, you would set up a box based on the number of terms in each one. So since we have a binomial times a binomial, you're going to use a 2x2 grid. You would fill in each term outside the box. So then I'm going to use red here to fill in the inside. You're going to do x times x gets you x squared. X times 7 is +7x. X times -4, -4x. And then -4 times +7, -28. So that's just a visual way of organizing the same exact thing we did with the arrow method, the distribution. And so now you're going to rewrite your insides here. We have x squared plus 7x minus 4x minus 28. And then you go back to looking for your like terms. So the +7 minus 4 are like terms. So you're left with x squared plus 3x minus 28. So you'll see you get the same answer as above. Either method works just as well, and if you had a trinomial too, you would just add another box depending on which direction you go, but Either method is great. Pick which one works best for you and just pick one and go for it. Okay, so now we're going to look at factoring. When we did the multiplication part, we had one factor. We started with x plus 7 as a factor, and then we started with another factor of x minus 4. We multiplied those out and got a trinomial. With factoring, we're going to work the opposite direction. You're going to start with a trinomial and move backwards to end up with two factors. So to factor, you always want to look for a GCF first. GCF stands for greatest common factor. After you look for a GCF, you're going to look for specific special cases. The first one would be a difference of squares. So x squared could be rewritten as x times x. So x squared is a perfect square. 25 could be rewritten as 5 times 5. 25 is a perfect squared. And then the difference means subtraction, and so those two things are being subtracted. The reason why that's helpful is because the factoring for those will always be your square root of each one with a plus minus in the middle, always. So if you have the difference of squares, so if you have two terms and they're each perfect squares, you can set them up by taking the square root of each and then just do that plus minus combo, and that will work every time. The second kind of special case is a perfect square trinomial. So what you want to look for is if your constant term is a perfect square, so we could write that as 4 times 4, and it happens to match this, the b term, which is your 8 right here. If your perfect square, your square root, could be 4 plus 4, then that is a perfect square trinomial. The reason why that's helpful is because your factoring will always be your square root of x squared, which is x, and the square root of 16, which is 4. And then because this is a plus sign, you're going to add both of those. So if you were to multiply that out, that would become x squared plus 8x plus 16, and that will work every time. So look for those two special cases because that'll make your factoring easier. If you don't have those special cases after doing the greatest common factor, you're going to use what we call ABC factoring. So your first step is to think of Beyonce and move it to the left to the left. So you're going to make sure if you have an equal sign, if it's an equation, you're going to move all of your pieces to the left. You're going to identify the ABC values. You're going to multiply A times C, and then you're going to find factor pairs of A times C that add up to B. You're going to expand the trinomial, which means you're going to replace the B term with the factor pairs. Then you'll do your factor by grouping and finish by double checking for another GCF. That's a lot of steps, so we will go through an example using all of those steps. So factoring, we start with the trinomial 10x squared minus 18x plus 8. First, we're going to look for a GCF. Our coefficients are 10, negative 18, and 8. We know that those all are even numbers, so automatically we know that there's a GCF of 2 at least, and that's actually the highest one. So we're going to start by factoring out a 2. You also want to check your variable term, but there aren't variables in each term, and so there's no way for there to be a GCF including a variable. So we're going to stick with our 2, and so you want to go through each piece and divide it out. So 10x squared divided by 2 would leave you with 5x squared. Negative 18x divided by 2 is negative 9x, and positive 8 divided by 2 is positive 4. So your goal with factoring is to simplify as much as possible. So right now we have two factors. We have the 2 and then this trinomial, but we're going to go through and keep looking. So after doing GCF, we would look for special cases. It's not a difference of squares because there's 3 terms in here. And it's not a perfect square trinomial because although 4 is a perfect square, the square root of 4 is 2, and 2 plus 2 does not equal 9 in that middle term. So that's not going to work. So now we're going to move to ABC factoring. So I'm going to do this in blue off to the side. So we need to identify our A, B, and C. So this is our A term is 5, our B term is 9, and our C term is 4. The next step is to multiply A times C. So A times C is 5 times 4, which is a positive 20. There's 2 ways to make a positive number. It could be 2 positives multiplied to be a positive, or 2 negatives multiplied to be a positive. We know that we're looking for factor pairs that add to be this B term, which is negative 9. So the only possible combo is going to be 2 negative numbers. So now we're going to find our factor pairs of 20. 1 times 20, 2 times 10, and 4 times 5. If we had both of these negative, Negative 4 plus negative 5 would get us negative 9, so that's going to be our factor pair that we're going to use. So we are going to now rewrite this trinomial and expand it. Instead of writing minus 9x, we're going to write minus 5x minus 4x and expand that b term, because now we can do grouping. When you have 4 terms like this, you can use grouping. We're just going to keep that 2 outside there. It doesn't really matter at this point. We've already factored that out, so we're just going to keep bringing it down. Now you're going to look for, within this binomial right here, what is a GCF of 5x squared and 5x? Well, that's going to be 5x. Then you'd open your parentheses and you're going to do 5x squared divided by 5x would just be x. And then negative 5x divided by 5x is negative 1. Now you're going to look at this binomial. We're looking for our GCF there. It's going to be a negative 4. When you do negative 4x divided by negative 4, you just get x. And when you have a positive 4 divided by negative 4, you get negative 1. Now, the whole point of doing that is you're going to look for twins, the identical factors there. So you're going to leave your 2 on the outside. You're going to copy your twin. I'll underline that so you can see where that comes from. And then the last part here is you're going to take these leftover pieces here and make that into one factor. So you're going to have 5x and then minus 4. So your final answer, your final factoring, is 2 times x minus 1 times 5x minus 4. If we were to multiply that all the way back out and using that distribution or the box method, whichever method you prefer, you would get back this original trinomial up here. So that is factoring. Just to double check, you always want to look through each of these factors and make sure there's no GCF within that. Like 5 and 4, they don't have a GCF, so you're good. You went as far as possible. So that would just be like a last minute check there. Okay, let's do one more example. We have 4x squared minus 9. So first you want to look for a GCF. 4 and 9 don't have a GCF, so we're good. Now you're going to look for special cases, difference of squares. So in order for it to be a difference of squares, each term would need to be a perfect square. Here we have 9, which could be 3 times 3. And then here we have 4x squared, which is 2x times 2x. We do have a subtraction sign in the middle, so we do indeed have the special case of the difference of squares. So we can go straight through. Instead of doing our ABC factoring, we can go straight to the factoring of different squares. So you're going to get the square root of 4x squared. You're going to put that in the front spot of each binomial. You're going to take the square root of 9, which is 3, and you're going to put that in the second spot of the binomial. And then you're going to do the plus minus combo. And without even going through all those steps, we already have our factoring. So the bottom line with this is if you can recognize this special case, then obviously we're going to save ourselves all the work we did up above. But if you don't see it, you could always come back to the ABC method. In this case, you would just have to make sure you are aware that your b is 0 because the b term is not there. There isn't one. The b term is always the coefficient of the x, and there isn't one in this case, so that's why the coefficient would be 0. So you could use the ABC method. It would just be a lot longer. So factoring is tricky. You want to make sure you do lots of practice on this. Always look for a GCF first. Always, always, always. And then, like I said, if you can recognize those special cases, your life will be a little bit easier. But then if you know for sure how to do GCF and the ABC, you'll be good to go. That'll work every time. So that's it for polynomials and factoring. Make sure you work hard and practice these problems.